Okay, so before I forget, two things. First of all, there's a quiz Friday. Remember, this Friday is also a half day like it was a couple weeks ago. So that's all we're doing Friday is the quiz, okay? And what the quiz is going to be on is only the stuff we talked about last week, which was only 2 days, right? We talked about adding and subtracting rational expressions. And we also talked about complex fractions. Okay, so that's what the quiz Friday is on. Any questions on that? So if you're a senior and you're not going to be here, you can be here if you want to, I don't really care. But if you're a senior and you're not going to be here, then just take the quiz sometime between 7:50 a.m. and 8 o'clock p.m. and that'll be your attendance for the day. Okay? And if you're in class, then you just take the quiz in class. That's it. In addition to that, there's a test next Wednesday. Which is the 9th. And it's just on everything we've done since the last test. So this includes rational expressions, including simplifying, multiplying, dividing, adding, and subtracting. It also includes complex fractions. And then what we did this week, which is undefined fractions, that's what we talked about on Monday. You just set the denominator equal to 0. That's when a fraction is undefined. Yesterday, we talked about x and y intercepts. And the whole concept there is to find x-intercepts, you set y equal to 0 and solve. To find y-intercepts, you set x equal to 0 and solve. And make sure when you're entering intercepts in on Delta Math, you got to enter them as points. So like an x value and a y value. But that's
yeah, that screwed me over so many times.
But doesn't it give you a chance? Like, doesn't it say? Like,
yeah, but I would think that I would just think that my answer was wrong.
Oh,
so then I would like be like, oh, maybe it's this, and then be like, and I'd be like, oh, I put that, and then be like, no, you gotta put it in this form, and I was like, yeah. Shut up.
Yeah, sorry. Yeah, so make sure you get it. And then what we're doing the rest of the week, and then on Monday, which includes a couple topics. Today we're going to talk about finding asymptotes, vertical and horizontal asymptotes. And finding holes in graphs. Okay, that's what we're talking about today and tomorrow, is asymptotes and holes. And then just graphing rational functions, which is kind of putting all this stuff together. That's what we're doing Monday. And then Tuesday is just the test review, and Wednesday will be the test. Okay? Any questions on that stuff? All right. One other final thing before we talk about the lesson for today is for attendance. I'm changing it slightly, which for most of you will have absolutely no effect on you whatsoever. But for some of you it will. For attendance, you still have 3 options to get credit for attendance on any given day, okay? You can either be in class. So if you're sitting here in front of me, there's nothing else you have to do. Okay, you don't have to watch a video or do anything or whatever. You just have to be here. Or the second option is you could be in the live Google Meet. So if you are Amanda or Abby right now, they're in the live Google Meet, so they automatically get credit for attendance. They don't have to do anything further. Or watch the video. Now, in the past, like before this week, I used to attach the video to Google Classroom, and you just watch it, and then you email me and say, I watched the video, right? So now you don't have to email me. You can just watch the video, but the video is going to be posted on Delta Math as an assignment. It's a YouTube video on Delta Math. So from your perspective, it's really no additional work. You just watch the video if you're not in one of these other 2 situations. If you're in class or you're in the live Google Meet, there'll be an assignment in your Delta Math that says, you know, watch this video and the deadline is tonight at midnight, but just ignore it. You don't have to watch it if you're in class or in the Google Meet. You only have to watch it if you're not in one of these other situations, okay? That way, what was happening is, like, on any given day, I have about 40 students that are remote that day, right? In terms of students that are always fully remote, and students that are in like the cohort that just doesn't happen to be meeting that day. So out of those 40 students, I would typically have like 15 students in the live Google Meet, and then 10 students who would email me and say, I'm watching the video. And then there's like 15 students that I would never hear from. And so it's like, it got to the point where I'm marking 15 students absent a day. There's something like wrong there, right? So this just helps me keep better track of like who's actually there and doing something and who is really truly absent. And I think it'll be
not emailing you.
They're just not emailing me.
Yeah.
So I think it'll be like less people that I have to mark absent that way. So from your perspective, it's really no different. If you've been emailing me, you no longer have to email me that you're doing the online lesson. That's the only difference. Plus, I'm hoping to become a rich YouTuber this way. We'll see. If that pans out, then I probably won't see you next year. But yeah, I probably would. I probably still would. I like my job. All right, so that's attendance. Really not that much different, but it's a little bit different. So you should just be aware of it. All right, so today we're going to talk about 2 things. We're going to talk about finding vertical asymptotes. And holes. So first of all, just graphically, I mean, you should know what these 2 things are, but a vertical asymptote is just a situation where you have a line, a vertical line, that the graph doesn't cross. So it might go like to infinity from one side, to negative infinity from the other side, or something like that, right? Like this is a situation that looks kind of like a 1/x graph, right? Or maybe it might do something like where it goes up from both sides, or maybe down from both sides, right? These are examples of vertical asymptotes. The graph never crosses it, it just keeps getting closer and closer and closer to it. A hole, on the other hand, is where there's just a single point missing from a function. This is just a single point missing from a function. So like it might be a linear function, like it might just be a line that's going along, it's missing a single point, and then it just continues along. It's like somebody just plucked out a single point. That's a hole, right? Or maybe it's a quadratic function that's missing a single point. Something like that. Okay, these are examples of holes in a function. And that's actually the technical name for it. It's a hole. Okay? Sometimes it's called a removable discontinuity, but don't worry about that. We can just call them holes. So there's an important fact that states that at any x value at which a rational function is undefined, there's either a vertical asymptote or a hole. At any x value at which a rational function is undefined, and we know that that is actually just where the denominator is 0, right? Where the denominator, that's what we talked about Monday. 0. At any x value at which a rational function is undefined, the function has either a vertical asymptote or a hole. Okay, so like for example, if I have a rational function like f of x equals 2x over x plus 3. I know that at -3, which is the only point where this function is undefined, there is either a vertical asymptote or a hole. At x equals -3, there's either a vertical asymptote or a hole. So the question is, how can you tell when there is a vertical asymptote and when there's a hole? Here's how you can tell. There will be a vertical asymptote if the denominator equals 0 and the numerator does not equal 0. And there will be a hole if the denominator equals 0 and the numerator also equals 0. So if, like in this example up here, if -3 gives me a 0 denominator and it doesn't give me a 0 numerator, which situation is this? Because -3 doesn't give me 0 on the top here, right? But it does give me 0 on the bottom. So at -3, is there a vertical asymptote or a hole? Vertical asymptote. It's this situation. The denominator is 0, but the numerator is not. So in this situation, there's definitely a vertical asymptote. But if you had a function where the numerator and denominator were both 0 at a particular point, then that is indicative of a hole. Like, for example, if I had something like f of x equals x times, sorry, not x times, just x squared minus 1 over x minus 1. Okay. If I look at where this denominator is 0, it's 0 at 1, right? So this is undefined. At x equals 1. But if I find f of 1, it's 0 over 0. It gives me 0 on the numerator and the denominator. So this fact right here means that there's a hole at x equals 1. Now, to determine exactly where that hole is, like you can find the y coordinate of the hole also. And the way you do that is you just simplify the rational expression and then plug 1 in. Because if I simplify this rational expression, I get x squared minus 1 over x minus 1, which factors as x minus 1, x plus 1. And then the x minus 1's cancel, right? So what that means is this function, x squared minus 1 over x minus 1, looks exactly like this function at every single point, except for at 1. And at 1, this one's undefined and this one's not. So let me write that. So f of x looks exactly like y equals x plus 1, but with a hole at x equals 1, right? Because we know there's a hole at x equals 1. So this function, f of x, looks exactly like x plus 1, but with a hole at x equals 1. So it looks like this. It's a line, right? X plus 1 is a line of slope 1, y-intercept 1. So it's going like this, and then it just has a hole right there, and then it just continues on its way. That's what this function looks like. It looks exactly like that. So to determine the y-coordinate of this hole, all you need to do is figure out what the y-coordinate of this function is at 1. And it's 2, right? You plug 1 into this expression, you get 2. So this point is at 1, 2. That's where the hole is, at 1, 2. Does that make sense? On delta math, when they ask you to find out where the hole is, they want an x value and a y value. So you have to make sure you enter in both. Don't enter in just the x value. And when on delta math, when they ask you to find the vertical asymptote, you won't say the vertical asymptote is -3. You'll say the vertical asymptote is x equals -3, because it's a line, right? It has to be the equation of a vertical line. X equals -3. If you just type in -3, it'll say it's wrong. Okay? It has to be the equation of a line. Let's do another one. Suppose I have something like f of x equals, how about this one? X minus 1 over x squared minus 4x plus 3. So here's what your process should be. Simplify the, actually not simplify, but factor the top and bottom completely. X minus 1, this bottom factors as x minus 3x minus 1. So the shortcut kind of is, if there's a matching factor, then that means that there's a hole where that factor is 0. If there's not a matching factor, like this one doesn't have a matching factor on top and bottom, it's only the bottom, that's going to be a vertical asymptote. Okay? So there's a vertical asymptote in this function x equals 3. That's the vertical asymptote part of this. There's a hole at x equals 1, but you have to actually find the y-coordinate that goes along with that. So to find the y-coordinate that goes along with that, you simplify the fraction as much as you can, which would be 1 over x minus 3, and then just substitute 1 into x here. Does that make sense? So the y-coordinate, if x equals 1, the y-coordinate is 1 over negative 2, right? 1 over 1 minus 3. So the whole is 1 negative 1/2. That's what you would say the whole is. The vertical asymptote is the equation of that vertical line. So just looking at the original function, this function looks exactly like this function, except for there's a hole at this point. So what does this function look like? If you remember, we did a section on graphing functions without a calculator. This looks like 1 over x, but shifted how? How is this graph different than 1 over x? Remember that stuff?
Oh, it's shifted to the right 3.
Yeah, good. We're replacing x with x minus 3, which means it's a horizontal shift, and that's the opposite of what you would expect. If it's plus, you move to the left, and if it's negative, you move to the right. So this moves to the right 3. So this graph looks like 1 over x, but shifted 3 units to the right. And there's a hole at the point 1 negative 1/2. So it looks like this. Looks like 1 over x, but there's a hole right there. That's what that graph looks like. The original function, this function right here, looks like that. You don't have to actually provide the graph, but I'm just showing you like that's what's happening here. There's a vertical asymptote at 3. You can see that from the graph. And there's a hole at 1 negative 1/2. You can see that from the graph as well. Does that make sense? Let's just do one more example. How about something like this? What if I have f of x equals 2x squared minus 18 over x squared minus 3x. So the top, I would factor out a common factor of 2, and then you get x squared minus 9. So it's going to be x minus 3x plus 3. In the bottom, you can factor out a common factor of x. And you get x minus 3. So now you look at where the denominator is 0. It's 0 at 0 and 3, right? Those are the 2 points that make this fraction undefined. At 0, since there's not a factor of x on top, that corresponds to a horizontal or vertical asymptote. There's a vertical asymptote x equals 0. But there's a matching factor with x minus 3. That means that there's a hole, right? So you can say there's a hole. Its x value is 3. And the y value you get by canceling the x minus 3's and looking at what's left. 2 times x plus 3 over x. And plugging 3 into here. If I plug 3 into here, I get 2 times 6, is 12, divided by 3, which is 4. So I have 3, 4. Everybody see how I got that 4? I just substituted 3 in here to determine the y-coordinate of the hole.
Wait, why did you say 3?
Because I know there's a hole at x equals 3, right? So the y-coordinate of this graph at 3 is the same as the y-coordinate of this graph's hole at 3,
Okay.
right? The graphs are identical in every way, except that one has a hole at 3 and this one doesn't. So I'm really figuring out what the y value of this one is at 3, which tells me the y coordinate of the hole. Does everybody understand that? Okay, so that's what the homework's about. Figuring out where graphs have vertical asymptotes. Make sure you enter the answer as an equation of a line. And finding out where a hole occurs, and make sure you find the y coordinate of that hole as well. That's it. Okay?